All right, here we go. This is our third on-demand intervention video, and as you can see on the title is everything you could need to know about surds that we can run through in about 30 minutes. Okay? So we're going to go through pretty much everything if we can fit it in. We're going to go through simplifying, multiplication, division, addition, subtraction, rationalizing, all these kinds of things. Okay? And we're going to see what we do with them, what we don't do with them, what we need to be careful of, all that kind of jazz. So we may as well get on with it. Let's go. So first things first, what actually is a surd? Well, as it says on screen, a surd is a root value that cannot be simplified. Okay, and when dealing with roots, we've got to remember that if we're evaluating something, if we're working out what something actually equals, square root should have a plus or minus value. Okay, so just let's have a look at a surd or two. So let's an example of a surd would be root 3. Okay, because root 3, well, there's no way for us to simplify it. If I type it into my calculator, I'm going to get a string of horrendous decimals. So it's easier for us to just say this thing is root 3. Okay, and if I did type it into my calculator and get decimals, I'd get 1.732050808, and it would go on and on and on. Another example of a surd could be root 5. Again, if I take root 5 and type that into my calculator, what it tries to do is to just give me root 5 again, because that is the easiest way for it to display that number, which would be 2.236 067977. And again, it carries on and on. And rather than dealing with this absolutely horrendous decimal, it's just cleaner and easier for us to use a root notation. Something which is not a surd would be something like root 64. Now, even though it's made up of a surd, I can actually say what root 64 is. It's plus or minus 8. Okay? Because we're looking at the values that multiply together to give us 64. 64 being a square number. Okay? I could also have something like the cube root of 27, which, again, you might think, actually, that looks kind of like a surd to me. But when we're thinking things that will multiply together 3 times to give us 27, what we actually end up with is 3. Okay? No plus or minus for cube roots. It's only square roots that have positive or negative values. And there are different ways that we can see a surd. The most common one is by using the root notation. So, for example, root 7. Okay? But we could also have something with a power of a half. So we could have 49 to the power of a half. Okay, and the power of a half is the same thing as us using a square root sign. Okay, so in fact, let's just change that. So rather than 7, it says 49, so that we can say that those two things are equal. We could also have cube roots. So the cube root of 64, that would be the same thing as us saying 64 to the power of 1/3. Okay, the denominator of your power links to what kind of root you are doing. So say that the denominator of your power was 5, you'd be doing a 5th root, which you could tell your calculator to do. Okay, if your denominator was 4, it would be your 4th root, which again, I would tell my calculator to do. So this is an example of what surds are. They are ways for us to write horrendous decimals instead using root notation. We have things which are not surds because these things can be simplified. And we have the notation where we can use powers of half or powers of a third if we're talking about cube roots. Okay, so that's the first thing. That's what a surd is. our first thing that we're going to look at in terms of skills that we need to be able to do is to simplify surds. Okay, and surds are most often simplified by splitting it up into a square number and something else. They might even be kind enough to tell us what that something else might be, but it might not. Okay, so we want to deal with the case of what if not. Okay, so let's have a look at this root 45 here. Now, I want to think of two things that I know that multiply to give us 45, but where one of them is a square number. Okay, now 45 is 3 times 15 or 9 times 5. Okay, well, 9 is a square number. Okay, so we can write this as root 9 times 5, which we can split up like that. Okay, this is one thing that we can do in terms of surds. We can split up a multiplication like this. Okay, root 9 is 3, so we'd get 3 lots of root 5. Okay. So root 45 is the same as 3 root 5. 40 to the power of a half. So again, getting used to these different notations, a power of a half is the same as us taking the square root. The square root, because our denominator is a 2. Okay. So root 40. Two numbers that multiplied together to give us 40, one of which is a square number. We can split that up into 4 and 10. 4 is a square number. Now, root of 4 is just 2. So that's 2 root 10. Now, 10, as we'll see, is one of our non-examples of us looking to simplify. Now, if we think of two numbers that multiply together to give 10, I could have 2 and 5, 1 and 10. Now, the 1 and 10 doesn't actually help us with anything. The 2 and 5, they don't simplify to anything. I can't do like the square root of 2 and make it just appear as an integer. It would stay as root 2. Okay, so that just makes it more complicated. So root 10 would just stay as it is. Okay. And what I don't want to do is I don't want to split it up into 4 and 2.5, because roots of decimals is just as bad as doing roots of normal numbers. I mean, in terms of like simplifying things down, you don't want to split them up into decimals. It just makes things horrible. Cube root of 40 for our third and final example. We will need to be careful with the type of root that we're doing, and that will change how we split things up. So the cube root of 40, if I do 4 and 10, I can't do the cube root of 4 or the cube root of 10, so I've got to think of something else. So this could be the cube root of 8 times the cube root of 5. Now the cube root of 8, that we can do, that's 2. Okay, sorry about that. So that's the same as us thinking 2 times the cube root of 5. Okay. And all of these things here, these are non-examples because we cannot simplify them any further than they already are. Root 10, root 2, root 5 doesn't simplify. Root 2, nothing that we can multiply together with one of them is a square number. And 12 to the power of a third, or the cube root of 12. Again, there's nothing that we can do in terms of simplifying that's going to make it any easier. So that's simplifying surds, and there's a whole bunch of questions in the worksheet that I've put together that does that. If you want that practice, you would now be able to have a go at some of those. Now, the multiplication thing, we've pretty much already seen how it works in our previous slides. We can take a surd like this one and break it off into two separate surds through multiplication. And the same will work in terms of division. Okay, so we can use a rule like this to do multiplication and division. So let's have a go at that. So root 2 times root 2, that will be the same as us doing the root of 2 times 2. Because rather than splitting things up, we can just put them back together again. Now 2 times 2 is 4. So root of 4, positive or negative 2. Okay, so we can just combine surds so long as we're multiplying or dividing. Okay, things like this don't work when we're adding or subtracting. Okay, that might be worth a note. This doesn't work for add or subtract. Okay. Right, so we've got this next one here. 8 to the power of a half. A half for a power is the same as a square root. So this is root 8 times root 7. 8 sevens are 56. Now, if I'm kind of being a little bit picky about this, I might not have actually done that. Okay, because I've got a surd here that I can simplify. Okay, so I'm going to just jump underneath in a different colour. Root 8 is the same as root 4 root 2 times root 7. Root of 4 is 2. Root 2 times root 7 is root 14. So that's going to be the same as 2 root 14. Now, you could take the long way round and look to simplify root 56, and you could eventually get to 2 root 14. But looking at what we've got at the start here, okay, that coming from this line here just means that we can maybe shortcut a few things later on. So what we got next, we got 2 root 5 times 3 root 10, okay? Now for this one, what we can do is we can combine the two surd parts. That's fine, because if I'm writing this out in long, what it is actually saying is this, where everything is being multiplied together. And it doesn't matter what order we do the multiplication in, because it's all multiplication. Okay? So I can do the 2 times the 3 and the root 5 times the root 10, and then see if I can simplify it down afterwards. So let's do that. 2 times 3 gives us 6. Root 5 times root 10 gives us root 50. Now root 50, I need to think, is there a square number and another number that I can multiply together to give us root 50? Well, yes, there is. There's root 25 and root 2. Root 25, that's the same as just 5. So I've got 6 times 5 times root 2. Now 6 times 5 is 30. So 30 root 2. Now, you can extend this into working with algebra as well. And the more that you do, obviously the higher your grade gets, or the anticipated grade at least. So let's see if we can just do something like this. 2 lots of root 3a times b lots of root ac. Interesting. Right, okay. Let's deal with the front bits first. 2 times b. 2b. Now let's put all of the roots together. So we got 3 times a times c. Now in there, I've got a little a squared. Okay. So I could have this as 2b root 3c root a squared. Now, square rooting, that's just the opposite of squaring. So if I square root something that's been squared, I just get the bit that is in the middle. So this would be 2ba root 3c. A little bit more kind of complicated. You've got to look for some little things like that when you're dealing with algebra. But the rule remains the same. You can split the root up or you can merge the root together so long as you're multiplying. And you could do exactly the same, just with a division, when you're dividing. So root 80 divided by root 10 is going to be root 80 divided by 10, which is root 8, which is root 4 root 2, which is 2 root 2. Okay, and if you're not sure what I've done there, I've split 8 so that it is 4 times 2. And then root of 4 is 2. I've got 2 root 2. Like we did with multiplying, I can do the same with division. I would divide my front numbers and divide my surds separately. So I'd have 60 divided by 2, which is 30. Root 6 divided by root 3 is root 2. Okay. And if I've got things like this where, you know, I've got fractions on the bottom, we're going to look at rationalizing the denominator in a little bit. That's going to be one of our things in the future. But we can do this a slightly different way. Okay. So because there's no root in our numerator, where it just says 50 on the top, I'm going to look to see if I can simplify this denominator and then see what's left. Now, root 50 we discovered in a previous slide. Did we not? Did we not? Yes, we did. We discovered here. But get the laser out. We discovered here that root 50 is root 25 root 2. And the root 25 is the same as just 5. Okay. So this is going to be the same as us saying 50 over 2 times 5 times root 2. Now 2 times 5 is 10. Okay. Now just as we had here in our second example, just there, when I had my 60 and 2, I could divide those coefficients, those front numbers, to get 30. So I can do the same here. I can do 50 divided by 10 and then be left with root 2 on my denominator. So 50 divided by 10 is 5, and that is 5 over root 2. Okay, and there's plenty of multiplication and division questions on the worksheet that I've put together. So yeah, go and feel free to practice those. Just remember that this works for multiplication and division, but does not work for addition or subtraction. Okay? You can split your roots apart, or you can merge your roots together, doing whatever is in the middle. Okay? Now that little warning at the bottom takes us nicely into addition and subtraction, which is perhaps a little bit more complicated than multiplication and division because of what I've written at the top here. Now, like with algebra, you can only add or subtract a surd if the surd is the same. Okay, like you can only add or subtract letters if they are the same letter and power. Okay, in this case, we can only simplify things that have the same surd value. Okay, if we do not have something which is the same surd value, then we cannot simplify them. Okay? So, for example, get back here. So, for example, for the first one, we've got root 2 plus root 2. Okay? Now, if I have one of something, and then I add another of it, that means that in total, I would have 2 of that thing. Okay? This does not become root 4. Okay? I cannot do that. Okay? I'm going to put in big red. This does not become root 2 plus 2. Okay? That is absolutely not what happens. Okay? We might need to check to see if we can simplify something first. Like I've got here with root 32 take away root 8. Now, when I'm dealing with things like this, I will typically look, can I make my larger surd, which in this case is root 32, can I make my larger surd match my lower surd? So I'm going to see, can I make root 32 break down into root something root 8? Now, in this case, we can. 4 8s are 32. So this is going to be root 4 root 8, take away root 8. Okay, using my multiplication rules, I've split 32 up into root 4 root 8. Now, root 4 is just 2. Now, in our first example, we said we had one of something, and we added another of it to get 2 of it. If I have 2 of something, and I take away 1 something, I will be left with 1 something. Okay? Just like I could say that 2x take away x equals x. Or the same way I could say 2/5 take away 1/5 equals 1/5. Okay? Just a matter of language. Okay? You have 2 of something, you take 1 away, you're left with 1 of your things. Slightly harder example again. This is probably something that would stretch you towards the grades, kind of the like higher grade 6 to possibly grade 7 scenario, something like this. But I would do exactly the same things I just did. Can I make my larger square root match my lower square root? Now, 20. One of them has got to be 5, means the other one has got to be 4. Root 4 is the same as 2. So this is going to be 2 root 5, take away 3 lots of 2, is 6 root 5. Okay? Remember, all of these things have got little multiplication signs that we don't bother writing in just because we're lazy. It's the same thing as you seeing like 3ab is 3 times a times b. If I have 2 of something and I take away 6 of something, that means that I'd be left with -4 of those things. Okay? And as we kind of alluded to in this little bit at the top, I cannot break apart a square root in terms of addition or subtraction. Okay? I just flat out can't do it. Okay? It cannot be done. The only thing that I could say for root of 3 plus 12 like that is that it would be root 15. That's the only thing that I can say about that. Okay? But root 3 plus root 12 is definitely not the same thing as root 3 plus 12. Okay? Definitely not. Now, Final thing, and we've got 5 minutes left, so this is like an ideal amount of time. The last thing we've got is something called rationalizing, or rationalizing the denominator. Okay. So we say that something is rationalized when a fraction does not have a surd in its denominator. To rationalize a fraction, we multiply the numerator and the denominator by the same surd. And the surd that we multiply is whatever it is on the denominator. Okay? So, for the example, this first one here, I would multiply that by root 5 over root 5. Okay? Now, if you're thinking at this point, but hang on a minute, that's just going to change our answer. It's going to be completely different. It won't be. Okay? The reason why it won't be is if you take something and divide it by the same thing, that's just going to equal 1. And if we times by 1, our answer doesn't change. So we can do this. It's perfectly okay for us to do this. 2 times root 5 is 2 root 5. Root 5 times root 5, that's the same as us saying root 25. Okay, remember our multiplication rules? So we've got 2 root 5 over root 25. Square root of 25 is 5. So this is 2 root 5 over 5. We have rationalized the denominator. And we can do exactly the same, even if it contains some algebra. So x over root 8, we would multiply the top and bottom by the same denominator. So we'd have x lots of root 8 over root 8 times root 8. Just the same as us saying x lots of root 8 over root 64, which is x lots of root 8 over 8. Okay. Now the last thing of this video, and we've got about 2 minutes left to do this, is rationalizing the denominator where we have a 2-term denominator, like you can see in our bottom example. In this case, and this definitely is the harder thing that you can do with surds, we don't just multiply by the denominator. What we multiply by is what we call the conjugate of the denominator. Okay, and if you are one of the people that goes in to look at further maths A-level, you'll come across conjugates again in terms of something else. For GCSE though, what a conjugate means is we take that sign there and change it to the conjugate is going to be 2 minus root 5. And what we do is the same as we did above, is we do the top and the bottom, but this time multiplied by the conjugate rather than just the normal surd. Now there's a reason for that, which you're going to see now. So my top is going to be 3 lots of 2 take root 5. And the bottom is going to be 2 plus root 5 expanded with 2 minus root 5. Now this is why there's that section in the worksheet which is just to do with expanding surd brackets. Okay? For that thing, we're going to want to make sure that we expand our surds properly, because some things are going to cancel out. So I'm going to draw in my little claw. So what's this going to be? This is going to be 2 times 2, 2 times negative root 5, which is negative 2 root 5, root 5 times 2, which is 2 root 5, And then root 5 times negative root 5, which is negative root 25. These two bits are going to cancel each other out. Because if you have negative 2 of something and then you add 2 of something, you end up with 0. We're going to have 4 take away root 25, which is 5, is negative 1. So this is going to be the same as 3 lots of 2 take away root 5 over negative 1. Which is the same thing as us writing negative 3 lots of 2 take root 5. If I wanted to go a stage further, I could expand that bracket. Negative 3 times 2 is negative 6. Negative 3 times negative root 5 is positive 3 root 5. Okay? Now I realise that an awful lot has just been said in terms of surds. Okay? Let's take things back. Surds are things that we would prefer to have written as a square root because their decimals are flipping nasty. Surds cannot be simplified. We can write it as a root of something or as a power of a half. We can split up a surd by multiplying, and our choice of numbers that we multiply together can mean that we can simplify things down quite nicely. Some things which cannot split up into a square number times something are left as that. These are surds. These are simplified surds. Multiplication and division, you can split or combine your two surds, provided that you do the thing that's in the middle. And if you have numbers at the front, do those numbers at the front with whatever you're dealing in the middle. Okay, so 2 times 3 gives us 6. Root 5 times root 10 is root 50. 60 divided by 2 is 30. Root 6 divided by root 3 is root 2. This does not work for additional subtraction. With additional subtraction, you treat it like you would treat algebra. Make it so that you've got the same thing that you're talking about and then add them together, being careful that you do your subtraction in the right way. Your square root should not change. Your square root should not change. For rationalizing, multiply the top and the bottom by the same surd, preferably the surd that's on the denominator of your fraction. And if you've got a 2-term denominator, you multiply it by the conjugate of your denominator, where you flip the sign over. And that is so the surd part of your expansion cancels each other out. Okay? There's an awful lot to go there, and I've gone 10% over time. So I'm going to leave it here. Feel free to use the worksheets that I've uploaded alongside this. They've got answers to go with it, so you can check what's going on. And if you do have any issues, either send me an email or if I've enabled it, put a post up on Teams under the intervention number 3 post. Okay? And I'll reply to your question, sorry. All right. There we go. Time for you to practice. Off you go.